Hey, Algebra 2, this is Mr. Morales. I am recording differently today because I'm back on campus and I don't have the same technology slightly that I had at home. Plus, I didn't make videos for this last year, so what we're going to do is we're going to learn to do this together. Well, not learn, I know how to do it, but I'm going to teach you how to do this in a more recent, I guess, video, so to speak. So let's go ahead and look at the top and let's begin with the three examples or the notes that they have for us. Now, the first thing we're asked to do is to create a table of values. And when you create the table of values, what you want to do is you want to make it so you have enough points before and after your vertex. So the first thing you're going to have to do is you're going to have to know how to find your vertex. And in order to do that, we're going to have to go back to a little quick formula we had. To get our vertex, now to get the vertex, it's an XY point. To get the X point, what you want to do is follow this formula. X equals negative b over 2 times a. Remember the coefficients a, b, and c represent our, represent the coefficients in the standard form for a quadratic formula. So if you know what a and you know what b are, you can always find the x value of the vertex and then find all the points that go before and after it. You'll see what I mean when we do the example. Next, just like when we did graphing inequalities in Algebra 1, remember the symbols tell you what kind of line you're going to have and what kind of shading you're going to have. Instead of having above and below, so to speak, of a straight line, you'll be shading either inside the curve going up or outside the curve going down or inside the curve, going down. So basically, you can either be inside the curve or outside the curve when you're shading. And it depends on which direction your parabolas open up to, depends on which way you'll be shading. But you also know that the line of the parabola changes. If you have just these plain less than or greater than arrows, then what you're going to have is a dashed line. If you have the less than equal to or greater than equal to symbols, then you're going to have a solid line. Then we're asked to shade above or below, like it says right here, based on the symbol. So let's go ahead and see what that means. So for our first example, what we need to do is find what is our vertex going to be, the center point that we want to start off everything right in the middle of our table right here. And in order to do that, we're going to go ahead and use our formula negative b over 2a. Remember, this is our a, the number of x squares you have. This is our b, the number of x's you have. And this is our c, our constant, which we're not using anyways in this formula. So when I plug in everything into this formula, I get negative of 2 over 2 times 1. When I simplify all that, negative 2 over 2 becomes a negative 1. So that's my starting point, negative 1. What I want to do now is pick points that come before negative 1 and then points that come after negative 1. Now, I went ahead and made a table of values. What you're going to do is plug in negative 1 into this equation for x and solve it, negative 2, negative 3, negative 4, and I'm going to save you the time, and I already had the table made on my side notes, so here's the answers you get. All right, 6, 1, negative 2, negative 3 is the lowest, and it goes back up to negative 2, 1, and 6. So what we're going to do now is we're going to go ahead and we're going to graph this graph. So using these points, we're going to go to negative 4, 6, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Put a point there, negative 3, 1, 1, 2, 3, 1. We have our a negative 2, 2, almost our vertex. Our vertex is at negative 1, 1, 2, negative 3, and then it goes back up like a mirror reflexively on the other side, just like that. Now, what we had originally, and if you can't see it, I'll go ahead and erase it. There we go, is a greater than symbol. That means we're going to have a dashed line. So I'll go ahead and change it up a bit. We're going to get a dashed line for our parabola. Arrow tips. Now, where are we shading? It says f of x is greater than. That means we're going to be shading everything above this line in a positive upward direction. So everything in here between the dashed lines going upwards forever will be shaded. Looks pretty cool when you do it on the iPad. So there's our first graph. It's pretty easy. It's a lot of rinse and repeat of the same thing over and over again. So what we're going to do now is let's quickly describe it, although you're not asked. The domain. For all these parabolas, as long as they open left and right in forever, then you're going to have an all real numbers, or the fancy little r like that for your domain. The range, however, always depends on where your vertex is. So in this case, we have a vertex down here, and the lowest point is at -1, -3. So our range, our height, is everything, our y is everything greater than -3. I didn't say equal to because we have those little dots, but whatever. So that comes up later on in your assignment. Just want to talk about that really quick. Moving on now, let's go ahead and do number 2. Same exact type of thing. We know our A is -1, our B is 4, and our C is also -1. So let's go ahead and use the formula to get the vertex. X equals -b over 2 times A. That means we're going to have -4 over 2 times -1. When we simplify that, we get a +2. That +2 now becomes our anchor point in our table for our vertex. So I want to pick points that come before 2, so 2, 1, 0, -1, and points that come after 2, 3, 4, and 5. And yes, I already do have a table created. It's going to be -6, -1, 2, 3, 2, -1, -6. And then now we're going to go ahead and make our graph. So it's using those points. We know our vertex is at 2, 3, 2, 1, 2. See, there's our middle point right here. And then we're going to have a point at, let's see, 1, 2. That means you have another point matching on the other side. 2, 3, excuse me, 0, -1. So I have another one matching over there. And then -1, -1, 2, 3, 4, 5, 6. Yes, 1, 2, 3, 4, 5, 6 here and here. Now, based on the symbol that we see, what kind of line are we going to have? And because it's less than or equal to, that means we're going to have a solid line connecting all these points with arrow tips on the bottom. Now, which way are we shading? Everything below this line, less than or equal to. So that means everything, in this case, going downwards and inside the parabola. All right, so here we go. Should have changed color to make it a little more interesting there. But there's number 2 for you. The domain is always all real numbers. The range is everything y less than or equal to +1, 2, 3. So the highest it goes. So everything below +3 has a y value. All right, here we go now, number 3. For number 3, thank God it's in standard form. So we're going to take, let's see, we need our A and we need our B, really. So x equals -b over 2 times A, which means we're going to get -18 over 2 times -3, which all simplifies to +3. +3 becomes our anchor point, so we're going to pick the points that come before. And then when we plug in those values into the equation, the following values we get are -22, -7, 2, 5, 2, and it goes back up again, -7, or back down again, -22. Now we're only going to graph the points that fit, so I'm not going to bother with these points here or here because they're not going to fit at all. They're just too far down. But the rest of these here in the middle will fit. So let's go ahead and graph those, and you change the color to make it a little more interesting. All right, so let's go ahead and do that. So our anchor point is at 3, 5. So +1, 2, 3, 1, 2, 3, 4, 5 right here. Then we have at 2, 2, 1, 2, 1, 2. That means we have another point on the other side of the vertex that matches it. And then at 1, -1, 2, 3, 4, 5, 6, it drops down really fast. Then we'll have the same matching point on, oops, right here on this side. What kind of line do we have? It's greater than or equal to, so we're going to have a solid line. And now we're shading everything, if you can't see it, greater than or equal to. That means everything above the curve, or everything above our curved line. So we shade it in just like this. So look, and now we don't shade inside the parabola, we're shading outside because it's everything above the line. It's a cool little feature when you're doing parabolas. It makes it a little more interesting than dealing with linear equations. All right, number 4. Let's go ahead and take it again. So we have an a of 1 x squared, but notice we have no x values, nothing with plain x. So that means our b is going to be equal to 0. And then we have c over here, which we don't need anyways. All right, so let's go ahead and plug in our formula. X is equal to -b over 2 times a, which means -0, which is no such thing. But we'll just say -0, 2 times 1. 0 divided by anything is always going to be just 0. So 0 is our starting point. We have the points that come before, the points that come after on the x side. All the values are 15, 10, 7, 6, 7. That is a 10. Let me go back in something, looks like a 6. And a 15 again. All right, we're only going to graph the points that do fit. So we have, sorry for the moving there, 0, 6, 0, 1, 2, 3, 4, 5, 6. And it opens upwards, which means we're not going to get too many points, except for the negative 1, 7, and the positive 1, 7. What kind of line do we have? It's going to be a dash line. So what we're going to get is opens upwards like that. And we are shading everything below this curve. So everything below the curved dash line gets shaded in. All right, I should have done a different color to make it stand out more. Let's go ahead and just change this a little bit. So here's our dashed parabola, and everything below it is what gets shaded in. 2 more examples, and then we're going to be done. It's a nice fast one today. So finally, let's try this again. We have x equals negative b over 2a. My b is going to be negative 2, so I have negative of a negative 2, which makes it positive. Negative b over 2 times my a, which is also negative 2. When I work all this out, I end up with a fraction, negative 1/2 for this one. So how are you going to handle that? Well, the same way we did before. Negative 1/2, it's a negative number. Let's pick the negative whole numbers now. So you don't have to stay in fraction land, so to speak. Even though it says there's a fraction involved, I'm going to pick all the whole numbers around that fraction to make my life a lot easier. I did already do the math. The answers we get are negative 12, negative 4, 0, half, 0, negative 4, and negative 12. I'm going to go ahead and graph these. So the ones that do fit are going to be negative 2, negative 4. Actually, I'll start with the vertex. Negative half, half, which is right like here, floating in that square. Then my other points are negative 1, 0, which means I have another one at 0, 0. And then I have, let's see, at negative 2, negative 1, 2, 3, 4. So there's one over here also at 1, 4, or 1, negative 4, and the other ones don't fit. What kind of line do I have? A solid line. Opens downward. We're shading everything less than or equal to this line, so that's everything below the line and inside it in this case, because you can't shade outside and still be below. All right, and then there's our graph. And finally, the last one. Actually, I'm going to leave this one for you guys to do and see what you get. So I'm going to be checking your notes to see what you get for number 6. Your assignment attached, same exact thing. Show me your work. Show me the negative b over 2a, either in your digital work or on your written work, and answer the questions. Show me the graph. Show me your table. Show me all those things, all right? Use Desmos for your calculations. It'll make the tables a lot easier and to verify your graphs, all right? It's a pretty fast lesson. If you need any help, feel free to ask me questions. Let me know. Otherwise, best of luck.